Here's where we left off. Reduction of aldehydes and ketones, which produces alcohols. Primary and secondary alcohols. Did you? No, you're not the one that lost your phone.
No.
No.
Thank you.
So, the hemiacetal reaction, and this is, I kind of emphasize this a little bit because it comes up in the it comes up in chapter 16 when we get to sugars. This will pop up again. So let's look at it simply. Let me look at the homework. You got the homework? Write a chemical. No, it's not the question I want. Oh, where's chapter 13? Well, where is the hemiacetal? Oh, there it is. It's on the second page. Ethanol with methanol. Okay, that's the. All right. So. All right, so let's take a little example of that. Let's take a very simple aldehyde. Let's take this very simple aldehyde here. Methanol. And let's take a very simple alcohol, pretty simple alcohol. We're going to use this alcohol. Now, I'm going to draw it. Sometimes I draw these molecules kind of funny just because of the bond that's getting involved in the reaction. So what I've got right here is simply ethanol. I mean, all I have there is ethanol. I mean, normally you would see it something like this, ethanol. But what I'm doing is I'm emphasizing this OH that's on the ethanol. I'm showing the oxygen-hydrogen bond that is there. We just write it as an OH. It usually is being carried along in an oxygen or in a reaction as an OH. But here, the OH is going to add across a double bond. All right, you've heard this time and time again now. Hydrogen adding across a carbon-carbon double bond, and each carbon gets a hydrogen. Hydrogen adding across a carbon-oxygen double bond, and the carbon and the oxygen each get a hydrogen. Well, now we got a little bit of a more complicated situation here. We have an OH. We don't have hydrogen. We have a hydroxyl adding across a double bond. And so what's going to happen, remember the way I kind of depicted this before, is we have a bond there made up of two electrons. That goes up in there, and the hydrogen goes on the oxygen. And this goes down into here, and the rest of the molecule, the rest of the ethanol goes onto that carbon through this carbon-oxygen bond. I know this is pretty fast for just being 5 minutes into the class, but, all right? But that's what's happening here. We're adding an alcohol across a carbon-oxygen double bond, and that's the hemiacetal. And this is a hemiacetal reaction. And so the end product is going to look like this. We're going to have an OH up here. And we're going to have the rest of the alcohol on the carbon. Notice that the only thing that's got involved here, I don't know if I can move this down much, is that original carbon-oxygen double bond is where everything's happened. We now have an alcohol there, and we have a ether We have an ether linkage there, and this is the hemiacetal. Kind of a strange name. Kind of a strange name. Now this probably won't clear it up for you, but the Earth is divided into two halves. The northern what? Hemisphere. And the southern hemisphere. So what does hemisphere mean? Hemisphere means half a sphere. Half of a sphere. All right? This will help you immensely, because now a hemiacetal is half of an acetal. You just never knew what an acetal was, right? This is half of one. I'm laughing. To me, this is funny. All right? This is half of an acetal reaction. If we go back over here, you can see that we got a carbon-oxygen double bond. We have an alcohol here. What kind of alcohol? Any alcohol. Any alcohol over here. And the O is going to go onto that carbon. The H is going to go onto that oxygen. See that H went onto that oxygen. And this OR, whatever it was, went onto the carbon. And that is the hemiacetal. And if we took that hemiacetal and reacted it with another alcohol, we would get the acetal. You don't worry about this reaction. Don't worry too much about that reaction. But what you see right here, it takes 2 alcohols to get over to an acetal. Just one alcohol gets you halfway there. And that's why it comes up with this strange name. It's halfway to an acetal formation. Okay, now the thing to keep in mind here, when you talk about hemiacetal, it's reacting with an aldehyde. So when you see acetal, it came about from the reaction of an alcohol with an aldehyde. And what you'll see in a moment here is that if you could do the same thing, you could react an alcohol with a ketone, but you get a hemiketal. Get a hemiketal. So that ketones can undergo this kind of reaction too, but they're referred to as hemiketals. You can see it right up there. Hemiacetal or ketal, depending upon whether it's reacting with an aldehyde or a ketone. All right, let's just look at a couple more slides. Well, let's just look at this reaction one more time. So if I were to write this just as a simple reaction, I would have methanol no, that's not that. I'm sorry. We're reacting. It's a hydrogen. Reacting methanol plus ethanol, and we're going to get this compound. It's going to be the product. And the name, don't worry about naming it hemiacetals. Just give me the structure, okay?
There's no hydrogen under the first carbon.
Is there? Yeah, there is. Wait a minute. Yeah, there is a hydrogen under there. Sorry. Yeah, you got 2 hydrogens on that carbon, and you're going to end up with 2 hydrogens on that carbon. It's got to have 4 bonds on it, yes. And don't worry about the name. Just get the structure right. There are a few other slides that just kind of go over this again and again. I don't really think they're very descriptive. You can see that as an aldehyde, an alcohol, You got your hemiacetal. So these ending slides are just kind of showing how this goes. Yeah, I really don't think these slides picture it. They look kind of complicated. I tried to make it a little simpler just the way I drew it. But if those help you, they do. Now, before I set you loose on you, so we got about 30 seconds, let's just look at these last two slides that summarize all of the reactions in chapter 13. Okay, these summary slides are pretty good. If you took a primary alcohol and oxidized it, you would produce an aldehyde. If you took a secondary alcohol and oxidized it, you would produce a ketone. So if you want to kind of have almost all the reactions on one slide, that's how you would prepare an aldehyde and a ketone. And then below that is showing you the way aldehydes and ketones react. An aldehyde will oxidize to carboxylic acid. A ketone does not oxidize any further. It's done. Does not oxidize. Hydrogenation of an aldehyde gets you a primary alcohol. Hydrogenation of a ketone gets you a secondary alcohol. And then here is your hemiacetal reactions. So an aldehyde plus reacts with an alcohol to form a hemiacetal. A ketone reacts with an alcohol to form a hemiketal. Is that all the reactions? We missing something? Let's see what this next slide has. Here's one more summary. This is this is the same thing there. Aldehyde reacts, oxidizes to that. There's the hydrogenation of an aldehyde or a ketone. Okay, the enol formation, the aldol condensation, we're not emphasizing. You should be familiar with the hemiketal and the hemiacetal reactions. And of course, hydrogenation and oxidation. Keep in mind that hydrogenation is reduction. So hydrogenation, reduction are pretty much synonymous, because what is reduction? It's either the loss of oxygen or the addition of hydrogen, and hydrogenation is adding hydrogen to a molecule. So by definition, hydrogenation is reducing the molecule. Why did that disappear? Okay, so 5 minutes, and bring your homework up when you're done.
Well, we have All of it?
Yeah, I didn't explicitly say, yes, they can. I mean, there was the last 2 pages that you had to write. It's either removal or adding a That's not butane. That's butanol.
It's on page 4.
And reduction of it means
For this one?
no, I think it'll be H2. That's so say H2 hydrogen, elemental hydrogen plus that. That's not. So you gotta get butanol. Find out what butanol is.
Is this?
I don't draw like that either.
The only H that's getting involved in the reaction is that OH bond is getting breaks. Hydrogen goes there. The oxygen that carbon, those 3 hydrogens don't get involved. They throw away the oxygen.
You're adding your Epsilon on that. And then you add this part.
Never had to do stuff like this. And we have to this, but I could bring it down as just, but start getting the other pretty much You know, you don't have to figure out what the actual formula is for iron. I can give it to you.
Oh, yeah.
At least in my
Is this correct?
if I add a hydroxide.
Yeah, that's correct.
They were just like,